So this is, I really should call this my broken record Ignite, even though this is my first one, because this is a subject that anybody who knows me knows I talk about all the time and I feel very passionate about. And it's this idea of the teacher-proof curriculum, which is this derogatory term that I'm hoping to provide an alternative to. And my alternative is the curriculum-proof teacher. And I'm going to tell you a little bit about who this teacher is. And I want to start by quoting Robert Moses and Paul Cobb from Radical Equations. They say, if you're struggling with an equation while doing your algebra homework, more likely your parent will look over your shoulder, wrinkle a brow, and say something like, I never got that stuff either, try not to fail. In effect, math instruction weeds out people. And I think one of the reasons why math instruction weeds out people is because we perpetuate this belief that no matter what teacher you have, if you have the perfect curriculum, kids are going to learn. Look, these kids are so happy and smiling because they had the perfect curriculum even though they had a zombie for a teacher. So clearly the curriculum is the big deal. But there's problems with this, as everyone in this room knows. No perfect curriculum yet exists. There's huge variability in how teachers use curricula. And most importantly, we know teachers make a difference. In fact, we know they make the difference in how students learn. And curriculum-proof teachers design effective learning experiences regardless of the textbook they're using. They attend to different kinds of knowledge. They maximize the effectiveness of the textbook that they have. And specifically, they think about ranges of student understandings and using assessment in better ways. And Jerome Bruner really talks about these ranges nicely. He says, intellectual activity anywhere is the same, whether at the frontier of knowledge or in a third grade classroom. The difference is in degree, not kind. As an example of that, if I told you I want you to draw a male human face, and you had 5 students do this, and I got these 5 pictures. Well, the picture on the left isn't necessarily male, it's not necessarily human, but it's not an elephant, it's not a chair, right? There's something happening there. The way that we look at standards, though, right now is very black or white. And we usually draw some arbitrary line where kids either pass or fail. But those 3 pictures on the left are all male human faces. They're somewhere in them. There's a lot of really fantastic understanding there. Here's another example. Here's a really typical systems of equations problem that you might see about phone plans. And a standard solves systems of linear equations exactly and approximately. Okay, well maybe a kid who did this the way that we would want them to do it, according to a checkbox, would set those 2 equations equal to each other, they'd solve algebraically, they'd get t equals 100 and conclude T-Bell is cheaper if you text fewer than 100 times per month. Okay, fine. But what if another student did something like this? They decide to make a table and they plug in some values for different numbers of text messages and they decide that it depends. If you don't text that much, you should get T-Bell. Lot of richness in that work, not exactly passing the standard as it's written. Or what about this student who maybe is trying to use a graphical approach, a very good approach to thinking about systems, but their precision is a little bit off. So they have parallel lines and they conclude correctly, T-Bell is always better. Well, what do we know about what that kid really knows? I try to help teachers think about these ranges from beginning understandings all the way to advanced. For systems of equations, we might think of things like being able to graph both lines, or estimating the point of intersection, or giving the solution as a coordinate, all the way up to the very advanced understandings that have to do with that, like solving a system using the elimination method, or perhaps solving a 3-equation linear system. And I think these ranges are really powerful and they're really subjective, because you're the one who knows your kids. The other piece of curriculum-proof teaching has to do with assessment. Assessment is crucial. Better assessment based on goals and these ranges of understanding, allowing all students to show what they know, and giving better feedback to us about what kids know, and better feedback to students. So here's an example of a test, maybe a test question on systems of linear equations. There's a system. You say, estimate the solution using a graph, be sure to show where the solution is, find the solution, there's some points here, 9 points, yeah, that sounds good, okay, 11-point problem, I'm going to give them partial credit if they do X, Y, and Z. Okay, that's one way to think about this. This is a very familiar kind of assessment system for math teachers. But what if you took that range I showed you before, from beginning understandings all the way up to advanced, and you put that on the test, and you have kids, when you give them their feedback back, you highlight the things that they show. So let's say a student does graphically draw the lines correctly, they do all of the algebra algebra wrong, or they leave that blank? What if you can highlight for them that they can correctly graph both lines in a given linear system? That's powerful feedback that's really powerful for the student and powerful for you. And when you flip through the top of your tests, it's better feedback. Dan Meyer gave me these textbooks. This is Larson from before Common Core and Larson after. 2 changes. The chapter number, and they list the Common Core standards. Textbooks are not going to be our help. Thank you.